This is problem 41 from page 154, and we are solving a quadratic inequality, and we're going to be sure to write our solution set in interval notation. Okay, this is called a quadratic inequality because we have x squared in here. If we had something else such as maybe 2x minus 9 is less than or equal to 18, this would be a linear inequality. And we could solve it very quickly, very simply, no problem. But that's not what we have. A quadratic inequality is a lot more complicated to solve. So this is going to take us a while. Grab a warm drink and sit back and let's tackle this thing. Okay, we are going to use a method known as the critical point method. This is not the only method, but it's a good algebraic method which has applications for other problems down the road, so it's a good thing to practice. The first thing we want to do is we want this to say less than or equal to 0, not less than or equal to 18. So I'm going to subtract 18 from both sides. 0 is important with inequalities because less than 0 is negative, greater than 0 is positive, so 0 is a really key number to involve. Okay, the first step in the critical point process is to find the critical points. The critical points are the x values that make the expression equal 0. Not greater than 0, not less than 0, but what makes the expression equal 0. Okay, so let's set it equal to 0. And this is factorable. Let's see here. I believe those are the factors. We can just do a little check of that, make sure, and then set each factor equal to 0. Solve each one, and you have your critical points. Okay, the critical points are x equals negative 3/2 and x equals 6. So what do we do with those? The next step is to use the critical points to divide the number line into intervals. These critical points are the numbers that make the expression equal to 0. We want to know what makes the expression greater than 0 and what makes the expression less than 0. So these are the dividing numbers. And if you like, you can actually draw a number line to help you visualize what's going on, going from negative infinity to positive infinity. And it has a break at negative 3/2, and it has a break at 6. Everywhere you have a critical point, you have a break in your number line. So we write the intervals as negative infinity to negative 3/2, negative 3/2 to 6, and 6 to infinity. You can write the intervals without drawing the number line if that's what you like to do. The next thing we do is we test the intervals. Pick a number in each interval and test it. I'm going to write this over here. Let's see. So let's pick a number from each interval, something between the two endpoints. So something between negative infinity and negative 3/2. How about if we test negative 2? Something between negative 3/2 and 6, we could test 0. And something greater than 6, we could test 7. Where do we test it? We test into the factors that we previously found. So let's go back and see where those are. We're looking for the factors. These are the factors. Okay, so we're going to take -2. We're going to plug it in for x into the first factor. 2 times -2 plus 3. That is negative. It doesn't matter what the number is. What matters is that it's negative. Take -2 and plug it into the other factor. -2 minus 6 is also negative. So we have a negative times a negative, which is positive. Move on to the next test number, 0. Plug it in the first factor. 2 times 0 plus 3, that's positive. Plug it into the second factor, 0 minus 6, that's negative. Positive times negative is negative. And 7, same idea, we get positive times positive, which is positive. Okay, so far we found the critical points, we made intervals, and we tested a number from each interval. The next step is to analyze the results. In other words, draw conclusions. What's the answer? Okay, let's go back to the original problem. So we were looking for what makes this expression less than or equal to 0. Less than 0 would be negative. If it said greater than 0, we would be looking for the positives. So we are looking for the negatives because it says less than 0. So going back, we see that we have negative right here. That's less than 0. So this interval it corresponds to is our answer. So our answer is x is an element of the interval from -3/2 to 6. Now, I could put parentheses around those, but keep in mind there's one other thing to consider. Looking back at the problem, it didn't just say less than 0, it said less than or equal to 0. So we need to include the endpoints, the critical points that made it equal to 0. So we are going to include the -3/2 and the 6. The way we show that is by making them square brackets instead of round. That means include endpoints. So there's our answer. That is in interval notation. If we were writing the same answer but we wanted to use set notation, I'll show you how that would look. So this is interval notation. Set notation which would be equivalent, would say x is between, so put the lower number first, -3/2 is less than or equal to x is less than or equal to 6. That answer is equivalent, it's just a different notation. And the last thing I want to point out is I would like to make a graphical connection between what we just did and another way to solve it. Okay, so let's take this expression that we started with, 2x squared minus 9x minus 18, quadratic expression. And let's say this is a quadratic function f of x. What we know about that is that it's a parabola. That parabola would open up, and it would have its y-intercept at the point 0, -18. So perhaps it looks something like this. Notice that over here we have positive y values. Over here we have positive y values. And down here we have negative y values. And the places where we switch from positive to negative are the places where it equals 0, the x-intercepts. That one happens to be -3/2, and that one is 6. So if you graph the parabola, you can get the same result you got from the algebra, which is that this goes from positive to negative to positive.